Hello and very welcome back to our channel. And this time we have brought to you a module number 2, that is electrical units and laws. So in our previous module, that is module number 1, we have covered the basics of electricity, and in this particular module we will talk about specifically Ohm's law. Power and energy, we'll see what they are, their definitions, and whether or not they are related to each other. And then we will see SI units. So if you are students, technicians, hobbyist, professional, and those who want to review your concepts, you can see and refer to this unit. We'll have this unit quite interesting now. So in this module number 2, there are a few objectives that we will talk about. First objective is to understand what is an Ohm's law, and we would see its practical application. So if you are pursuing electrical engineering, electronics engineering, this Ohm's law is very important to understand, and most important again to understand where it is applied. Second is we will see what is a power in the basics of electricity and what is an energy in the basics of electricity, and specifically in electrical and electronic circuits, what power and energy are, and we would see how to calculate them. The third objective is in today's module is to learn about the SI units that are used for measurement. So when you are doing some electrical measurement of quantities such as voltage, current, resistance, power, energy, etc., etc., we need to know how these measurements units are used. When you are measuring, for example, voltage, how is the voltage measured and in what unit it is expressed. So let us start with the Ohm's law, the basic concept that we will review here. So definition of the Ohm's law is very simple. V equals to I times R, where you see that the V is the voltage, I is the current, and R is the resistance. And in parentheses, for each of these quantities, you see their voltage is given in volts, current is given in amperes, and resistance R is given in ohms. So here is a simple electrical circuit where you see the voltage source V. You have a resistance in the circuit, and since the circuit is closed circuit, you have a resulting current flowing in the loop, that is I. And obviously the formula for Ohm's law is V equal to I times R. So it's a linear relationship. You can also express the Ohm's law by two other formulas, which are basically the interchanging of the quantities right here. Here we see the voltage is equal to I times R. So if you want to calculate R, you simply take I to the left side. V divided by I would be your R, which is given right here. So again, R equal to V divided by I. For example, you want to calculate I from the same formula again, take the R to the left side. So V divided by R would be your I, which is what we have written here, I equal to V divided by R. So Ohm's law would be given or expressed by these three formulas, V equal to I times R, or you say R equal to V over I, or you say I equal to V over R. Now, so finally, we would conclude that Ohm's law is basically explaining us the relationship between the voltage, current, and the resistance in an electrical circuit. That is how and what an Ohm's law is. So what are the real life applications in which we can see the use of Ohm's law? First of all, we can see that we can calculate currents in the circuit. Second is we can determine the resistance values, or in other words, we can also calculate the resistance in the circuit, what we just saw in the previous slides. So For example, again, the same circuit is given. You see the voltage source resistance. Obviously, the circuit is closed circuit, therefore the current is starting to flow. And the example problem given to you is, let's say the voltage here is 12 volt right here. Resistance R is 6 ohm, and you are asked to calculate current I. So if I ask you to go back to previous slide, you will see easily we know the formula to calculate I. So obviously here we have applied the formula for I, that is V over R. V is 12 volt, R is 6 ohm, and that is why the current resulting current is 2 ampere. So there is now this quiz for you. There are two quizzes. Quiz number one says you are given I equal to 1 ampere. So let's say I is given 1 ampere. R is also given, that is to be 6 ohm. You are asked to calculate V. So we know that V equals to I times R. That is the formula. In second quiz, you are given V equal to 10 volt, I equal to 2 ampere, and you are asked to compute R, which is the ratio of V over I. So obviously you know the formulas for these two. Write, calculate them, and write your answers in the comment sections. Now we move to the second objective, that is understand what is a power in the electrical circuit. So simple formula to calculate a power in the electrical circuit is power P is equal to V times I. There are two alternate forms by which we can calculate the power in the circuits. That is, P equals to I square times R. I is the current, R is the resistance. Or we can also calculate power P equals to V square divided by R, where V is the voltage, R is the resistance again. So what are the practical examples to understand what is a power in the electrical circuits? So the first example, you can see that you supply an electricity to a light bulb and light bulb glows, and when it glows, it consumes some amount of power. So that is basically a power in the electrical circuit. Second example, again, we can refer back to the previous circuit that we understand. Here, you supply the voltage to the circuit by means of this voltage source. You have a resistance in the circuit and you have closed the circuit, you have closed the loop. Therefore, the resulting current I started to flow. So if you want to now calculate the power in the circuits, you can do that by using these formulas. Earlier we have seen how to compute voltage, current, or resistance. Any one quantity can be calculated if the other two quantities are known out of V, I, and R. That is an Ohm's law. But how about power? To calculate the power, you can use these formulas. So we'll see how we actually can calculate the power. So here you see that example is given. You have given the voltage source, resistance R, closed loop, and the current is flowing. Now, voltage is 12 volt, resistance R is 6 ohm. So you are asked to find a number A, power delivered or sourced, and number B, power absorbed, sinked, or dissipated. So we have to distinguish between what is power delivered or sourced and what is power sinked or absorbed or dissipated. So you can see that when you have a voltage source and it is connected to the circuit consisting of resistor, the resulting current is starting to flow. So the power delivered or sourced into the circuit is given by P equals to V times I. Now V is known, but I is unknown. So what is the first thing that you would need to do? You will need to do calculate the value of I. So I would be obviously V divided by R. And we know that voltage is 12 volts divided by 6 ohm is the resistance. Therefore, this would be 2 ampere. Okay, so you got the current that is 2 ampere flowing into the circuit. Now, power is easy to calculate. That is V times I. What is, we know that V is your 12 volts and 2 ampere. So here you have 24, 12 into 2, 24 watts is the power delivered. Now, the second question is, what is the power absorbed or sinked or dissipated? Because you have a power delivered to the circuit is 24 watt, there is some element into the circuit, for example, resistance, that is absorbing the power or sinking the power into the circuit, or you say the power is getting dissipated in the resistor. Okay, so that power, you have two formulas, that is I P equal to I square times R, or V square by V square divided by R. So what you can do here is simply, let's say the power you're calculating now in a proper way, that is your power delivered, power dissipated would be I square times R. So I is your 2 ampere, which is 2 square times 6 ohm. So that comes out to be 24 watts. So you obviously you see that power source and power absorbed is equal. You can also use this formula V square divided by R, which is 12 square divided by 6 ohm. Okay, so that would be like 144 divided by 6. Again, that comes to be 24 watts. So again, power absorbed and power sourced are same. And that is how the circuit work in this way. Okay. Now, let us move back to the second concept, that is energy in electrical circuits. Now, energy and the powers are related to each other. So, formula to calculate the energy is very simple again. E equals to P times T, where P is the power or T, time, is the energy. So, can I write, if this is the case, can I write P is equal to energy over T? Okay, so the power is energy over time. So you can see that these two formula are related to each other. Now going back to the discussion of energy, energy is measured in joules. So the unit of energy, always remember it is in joule, or you can also express energy in kWh, that is kilowatt hours. Okay, so now example problem. It's time to review what is an example problem here. So we will see that, let's say you have this electrical bulb, which is having a rating of 100 watt. Okay, that is your rating, a power rating of, remember this is watt, it means it's a power consumption. So 100-watt bulb runs for 5 hours. You switch on the light inside your home and you let the bulb to go on, light on for 5 hours, and its rating is 100 watt. Now you are asked to calculate the energy. So obviously you know the power, you know the time. So that's how you will see that energy is equal to 100 watt multiplied by 5 hours. That is the time. So that is 500 watt hours, or you can say 0.5 kilowatt hours. Remember, this is the power unit. This is the energy that you expressed it. Okay, time is always in hours. Okay. So now coming back to our SI unit of measurement, this is the final objective that we wanted to attain in this module. So the standard units are as below. You express voltage in volts, you express current I in amperes, You express resistance R in ohms. You express power P in watts. You express energy in joules. So there is a formula to convert the energy from kilowatt hours into joules or vice versa. So you can always say 1 kilowatt hours is equal to 3.6 into 10 to the power 6 joules. Okay, so exercise for you now. 1 joule would be how much? Obviously, you have to do the interchanging of the numbers here. So summary of this module 2 now, there are following key points that we will review. We have reviewed and understood Ohm's law that relates voltage, current, and resistance in the circuits. Next, we reviewed and understood what is a power, what is an energy. We understood how to calculate each of them, and we saw how their applications are in the circuits. Then we reviewed and understood the SI units to measure different quantities, whether it is voltage, current, resistance, power, or energy. So that's all. In the next module, we will review electrical circuits, for example, series and parallel connection of the components of the electrical components, and we'll see how to compute all these quantities such as voltage, current, resistance, power, energy, etc. And we have already covered a few other modules. They are available. So if you are new, you can refer to those. If you like this module, share it with others for a wider reach, and stay tuned for more and more engaging content like this. Till then, wish you a very happy learning. And yeah, that's it.